Welcome to Module 1, How Reading Works, the Science Made Simple. In this module, we're going to unpack what's happening in the brain when a child learns to read and connect the science directly to practice. This module pairs with my Kickstart to Phonics Teacher's Guide. It's a free guide you can get online at my Teachers Pay Teachers store. This guide serves as a companion for all the modules. The link to the guide is in the comments below. One of the most important truths in reading science is that reading is not a natural process. Let me say that one more time. Reading is not a natural process. Humans are wired for spoken language. We pick up speech through exposure and interaction, but written language is different. The brain has to repurpose existing systems for vision and sound to make sense of print. When a child sees the word cat, nothing about those three shapes, C-A-T, automatically tells the brain what sounds they represent. We have to teach students that C stands for k, A for a, and T for t, and then how to blend those sounds together. This is why guessing from pictures or memorizing word shapes doesn't build real reading. The brain needs sound symbol connections. Reading is learned step by step through instruction. Reading science doesn't come just from one discipline. It's built from several fields working together. Cognitive psychology looks at how memory, attention, and processing speed affect learning to read. Cognitive science studies how the brain handles symbols, patterns, and complex texts, like decoding. Educational psychology examines how teaching methods, practices, and motivation influences reading outcomes. Linguistics explains how sounds, words, and grammar are structured, and this is critical for phonics and comprehension. Science-based reading research pulls together findings from all of these areas to test what actually works in classrooms. When we say science of reading, we're talking about this combined evidence base, not a program, not a fad, but decades of research guiding us towards more effective instruction. From the research, we get some key guiding principles. Number 1, we are not born wired to read. Reading must be taught intentionally. Number 2, students must be taught to crack the code. They need clear instruction on how letters represent sounds. Number 3, instruction must be explicit and systematic. We don't rely on discovery or guessing. We model, we practice, and we build skills in a logical sequence. And number 4, reading comprehension requires both decoding and language. Students must be able to read the words and understand them. You might think of decoding as the key and language as the room you're unlocking. Without both, students can't fully access the text. The Simple View of Reading from Goff and Tummer from 1986 gives us a helpful equation. Decoding times language comprehension equals reading comprehension. Decoding is the ability to read the words accurately. Language comprehension is understanding spoken language like vocabulary, sentence structure, and background knowledge. If either side is weak, overall comprehension suffers. A student who can sound out every word but doesn't know what those words mean will still struggle. A student with strong oral language but weak decoding can't access the text independently. This model helps us diagnose where a student's breakdown is happening and reminds us that we must teach both sides deliberately. Scarborough's rope, developed in 2001, takes this idea and shows it visually. It has two main strands: word recognition, which includes phonological awareness, decoding, and sight recognition; language comprehension includes background knowledge, vocabulary, language structures, verbal reasoning, literacy knowledge. Each strand is made of smaller threads that strengthen over time. As students gain more practice and exposure, these threads weave together into skilled reading, fluent, accurate, and meaningful. This rope reminds us that reading is not one skill, it's a braid of many skills working together. When one thread is weak, the rope is less sturdy. Now, for our modules going forward, we will be focusing on the word recognition piece of Scarborough's rope. But let's first dig a little bit deeper into both sides. Let's zoom in to the word recognition strand. This is the part of reading that deals with getting the words off the page. Phonological awareness means hearing and manipulating sounds in words, like blending, segmenting, and manipulating phonemes. Decoding is using phonics knowledge to read unfamiliar words by applying sound-symbol relationships. And sight word recognition, or sight recognition, is instantly recognizing words that have been stored in memory through orthographic mapping. When these skills are strong, students don't have to labor over each word. They can read more smoothly, freeing up mental energy for understanding the text. Now we zoom in on the language comprehension strand. These are the skills that help students make sense of what they are reading. Background knowledge brings what students already know about the topic or the world. Vocabulary is the words they understand when they hear them or read them. Language structures is the grammar and the sentence patterns that help them understand complex text. And verbal reasoning are skills that, like making inferences and understanding figurative language and following arguments. And finally, literacy knowledge is knowing how different text types work. So how do stories work? How do informational text work? How does poetry work? Even a strong decoder will struggle with comprehension if these language skills are undeveloped. That's why read-alouds, discussion, and content-rich instruction are so important. So you heard me before say the word orthographic mapping when it comes to sight recognition. Orthographic mapping is the process that the brain uses to store words so that they can be recognized instantly. So in our slide, you see phonemes, graphemes, and meaning, and they're connected to orthographic mapping. That's the core idea. Phonemes are the individual sounds in words. Going back to the word cat, k, a, t. Those are the individual sounds in the word cat. Graphemes are the letters or letter combinations that represent those sounds. So looking at the word cat again, C-A-T are the graphemes. Meaning is what the word represents. When a student repeatedly and successfully connects the sounds, the letters, and the meaning of the word, that word becomes mapped in memory. It turns into a true sight word, not because the student memorized its shape, but because the brain has built a strong sound, symbol, meaning connection. Let's look at that a little bit further. So on this slide, it's showing you several components of how the brain stores words. In the front of the brain is the articulation and pronunciation part of your brain. This is how the word is physically said, so how we say the word cat. In the back of your brain, you can see the phoneme grapheme correspondence part. This is how sounds link to letters. So when they are learning the sounds in the word cat, this is where they're going to be storing those individual sounds. The meaning at the kind of the middle bottom piece represents what the word means. So they have a visual picture and they know what cat means. And the visual word form part in the bottom right of your brain is how the word looks in print when it has been mapped in your brain. So that is where words are stored that they can automatically recall when they're reading or when they're spelling. So let's look at another example. A student hears the sounds sh, I, p. They connect those sounds to the letters S, H, I, P. So the front of their brain, they hear ship, they know what it sounds like, and now they can connect it to letters because they have learned those individual graphemes and what sounds those make. And they understand what a ship is. A ship can be a vessel, a boat. It can also be meaning like you ship a package. And then after a lot of many successful encounters with reading and writing the word ship becomes mapped in your brain. And this is where it stores in the visual word form memory. So it's automatic. Kids can automatically spell it. They can automatically read it. So this whole action of what we're doing in our brain when we are learning a word is called orthographic mapping. It's when we're using the sounds, the phonemes, when we're using the letters, the graphemes, and when we're using meaning. And we know all of those things, and we've done a lot of practice with those sounds and those letters and the meaning, and they are building strong connections, and they are storing that in their visual word form area. So one powerful reminder from all this research is that exposure matters. So the number of exposures needed may vary depending on the student. So a student who is a gifted learner that catches things very quickly or catches on to things very quickly may only need 1 to 4 exposures for a skill to master it and have it store in their word form or visual word form area of their brain. And it becomes sight recognition at that point. A typical learner, your typical student in your classroom, may need 4 to 14 times of exposure and meaningful exposure. A struggling student might need 14 to 40 exposures. And then a student with dyslexia may need 40 to 200 exposures depending on their severity of dyslexia. So this tells us that repeated practice is not overdoing it. It's essential. Some brains map words quickly. Others need many more successful encounters. Our job is to provide enough accurate, supported practice so that every student's brain has the chance to build those connections, no matter how many repetitions it takes. So this slide shows the 5 components of literacy: phonemic awareness, phonics, fluency, vocabulary, and comprehension. These components work together like gears in a machine. Phonemic awareness and phonics drive decoding, and that is what the majority of these modules are going to be about and what my phonics curriculum is about. But it's also important to note we must provide instruction on vocabulary and comprehension because that drives meaning. So even as they're learning words and learning sounds in phonics and phonemic awareness, we must be connecting it to meaning and making sure they understand what they're reading. And fluency is the bridge that allows the students to read smoothly enough that they can focus on understanding. So again, we need to get these phonics skills into their visual word form memory so that things become sight recognition and fast, so that fluency can build and students can read accurately and quickly so that they can free up part of their brain for comprehension. So a strong literacy block, a strong instruction in language arts doesn't treat these as isolated pieces. It weaves them together. For example, a decodable text can support phonics and fluency, while a rich read aloud can build vocabulary and comprehension. The final thing I want to talk about today in Module 1 is what makes phonics effective. So I mentioned the two things before about explicit and systematic, and I want to also talk about cumulative. So what I mean by explicit is that we clearly teach the relationship between phonemes and graphemes. For example, if we are teaching the vowel team AI, we explain that it represents the long vowel sound of A, and we model how to read and spell words with it. And we're offering a lot of that practice because we have different types of learners in our classroom that may need more practice than others. Systematic means that we follow a planned sequence of skills, moving from simple to more complex patterns. So you'll later discover in another module that I have a scope and sequence. It's very important to evaluate your scope and sequence when you're teaching phonics to make sure it moves from simple to more complex patterns. So with that sequence there, students aren't left to discover patterns randomly. We guide them through a structured progression. And finally, cumulative means that students don't just learn a skill once and move on. They need 4 to 6 weeks of review and application to reach mastery. If you're familiar with Wiley Blevin's work, he says we can't be one and done. 4 to 6 weeks of continued review. So we purposely build in cumulative review of things we've already learned to give them more and more practice in order for it to become accurate and automatic, and that helps build the fluency so we can free up brain energy for comprehension. So this means that we must spiral back to previously taught things in reading and writing so that they stick. So when phonics instruction is explicit, when it's systematic, and when it's cumulative, it becomes a powerful tool for helping all students crack the code, not just ones who catch on quickly. And in Module 2, I'm going to discuss with you how we get started with students by assessing where they currently are and how we use that assessment tool to drive our instruction.